All right, guys, so this is ellipses versus hyperbolas, and how they're alike, how they're different. So for some reason, the way that this chart printed was a little weird. This should just be c squared up here, and this should be a continuation of orientation because there's going to be two different types that we see. So let's start with a squared. I'm going to go left to right here. We're going to compare the a squared on the ellipse and the hyperbola, and then b squared, and then just go down from there. So for the ellipse, the a squared is always going to be the bigger denominator. But we saw with hyperbola that that wasn't the case. It's always the first denominator with the hyperbola. With b squared, since a squared is always the bigger one, b squared will always be the smaller denominator. All right, and then since it's the first one, a squared is first with the hyperbola, that means it will be the second denominator for b squared. All right, talking about c squared. For ellipse, we were subtracting a squared minus b squared is equal to c squared, which is the square root, well, plus or minus square root of a squared minus b squared is equal to c. All right, and then for hyperbola, we were adding them together. We have a squared plus b squared is equal to c squared. Which is plus or minus the square root of a squared plus b squared is equal to c. All right, you can focus more on this aspect here because I know you guys can solve once you kind of plug in the numbers here. Okay, orientation, that means horizontal or vertical. So when it is horizontal, for one, it looks like a left to right oval. The a squared is under x squared. That means that the larger denominator is under x squared. If it is horizontal for a hyperbola, and that's where it looks kind of like that, x squared comes first. Okay, for the vertical, just more of like an up and down oval. The a squared is under y squared. And then for the vertical hyperbola, it looks more up and down. Y squared comes first. So that'll be the first way that you can kind of identify how your graph is going to look, whether it's an ellipse or a hyperbola. All right, and the last thing is the equations. So we have the x squared over a squared plus y squared over b squared is equal to 1, or we have x squared over b squared plus y squared over a squared is equal to 1. Either way, it will always be addition here. So that's going to be your first way to identify if it's an ellipse or a hyperbola because their equations are so similar. All right, and then if it's a hyperbola, we'll see x squared over a squared minus y squared over b squared is equal to 1. Or, and I forgot to put that here, or we will see y squared over a squared minus x squared over b squared is equal to 1. And again, your biggest identifier is going to be this subtraction sign in between them. As long as it's equal to 1 and there's a subtraction sign on the left, you'll know that it's a hyperbola. All right, let's look at the first example. So here we're going to identify which type it is, orientation, if it's horizontal or vertical, and then a couple different pieces of it. So let's look at the first one. We have, first things first, I see an addition sign. So right away I know that it's an ellipse. All right, orientation, is it going horizontally or vertical? Well, a squared, which is always the bigger denominator, I see that here, is under the x. That means that it's going to be horizontal. All right, which means it's gonna look more this way. All right, my center. Okay, so this is where you have to find the center. The center is not just the origin in this case because there are numbers involved on the top. So you would have to look at that as if x minus 2, you would basically set the numerator equal to 0 for both of them. So that means that x is 2, and I'm coming up with a coordinate here. So then we have y plus 3 is equal to 0. That means y is equal to negative 3. And I've created the coordinate of the center just by setting both the numerators equal to 0 and solving for x and solving for y. All right, so we have 2, negative 3 as my center. So I'm going to go ahead and put that point here. All right, let's talk about my A and my B, my vertices and my co-vertices. So the vertices are going to be, let's talk about a squared is equal to 25. That means a is equal to plus or minus 5. And since it's under the x, it'll be plus or minus 5, comma 0. For the co-vertices, we've got b squared is equal to 16. That means b is equal to plus or minus 4. So 0, comma, plus or minus 4, since it's under the y. So from the center, I will go 5 right and 5 left. All right, you're just kind of sketching what it looks like. And for the co-vertices, I will go up 4 and down 4. And just kind of sketch it from there. So it's a little bigger left to right than it is right to left. And just to kind of confirm here, I've got 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, and then for the focus, we have a squared. 25 minus 16 is equal to 9. So if c squared is equal to 9, that means c is equal to plus or minus 3. And since my a is x, it's larger, it'll be plus or minus 3, comma 0. So that means the focus is going to be 3 to the left, 3 to the right. All right, we've got one more we're going to do. So technically, since there's no denominator here, it's kind of the same as just putting it over 1. And we have a subtraction symbol, so that means we've got a hyperbola. Orientation. If it's horizontal, if x comes first, and it's vertical if y comes first. Since we have y in the front, we know that it is a vertical graph. Our center, we're going to find it the same way. Since there's nothing with x, we know that the x is just going to be 0, and y will be 3. All right, so that puts our center just up, shifted 3 units. And then a is always the first denominator. So a is going to be, we're going to have a plus or minus 1 here. Our b, which is the second denominator, is going to be, if 4 is equal to b squared, then b is equal to plus or minus 2. And then to find c, we have a squared plus b squared, which is just 5, is equal to c squared. And then c would be equal to plus or minus 5. Oh, square root of 5, sorry. All right, so here we go. So to find our vertices, it is always going to be where a is, which is the plus or minus 1. And since it's under the y, it's going to be up or down 1. So we have 0, comma, plus or minus 1. So we have up 1 and down 1. And I'm just going to focus on the asymptotes from here. So we will have y equals, and we're going to write it just in an mx plus b formula. We have the square root of the y denominator, which is 1, and we'll do a plus or minus, over the square root of the x denominator, which is going to be 2. All right, and usually we haven't had a plus b, but because our center is 0, 3, we're going to create an additional 3 to that. So from here, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and that is how you'll create your asymptotes. Over 2, down 1, over 2, down 1, up 1, left 2, up 1, left 2, up 1, left 2, down and right, down and right, down and right, down and right, down and right. And that is how we create our asymptotes. And from there, you can kind of just draw your graphs. So since it comes here, I know it's going to go somehow this direction and this direction. All right, and that is our ellipse and hyperbola.